Thank you for watching Hack the File. I'm Michael Lopez, and today we're going to be finishing up the fuzzing chapters in the Ethical Hacking book series. Enjoy. All right, so today's Halloween version. Let's go ahead and try to finish up this chapter so we can get into the really good stuff. I mean, this is really good stuff too, but I want to get into some, building Trojans or passing antiviruses and stuff like that. So let's go ahead and pick this up. Symbolic execution. Wouldn't it be amazing if we could analyze a program without executing it? Symbolic execution is a technique. We might skip this or just go through this quick. Symbolic execution is a technique that uses symbols instead of real data to perform statistic analysis on a program. As the symbolic execution engine explores paths in the program, it builds paths, equations it can solve to determine when a particular branch will be taken. Figure 9.6 shows the path constraint associated with the test function we explored earlier. Alright. To programmatically solve these path constraints, we use something called a theorem prover. Theorem prover answers questions like, is there a value for x such that x times 5 equals 15? If so, what is the value? The Z3 theorem prover is a popular prover developed by Microsoft. A detailed discussion of theorem proving is beyond the scope of this book, but we'll consider it in the context of our test program. Hold on, I gotta open this window. It is hot in here. It's Halloween time, so I've got the heat up. Now I've got it too hot. Okay. A symbolic execution of the test program. The theorem prover helps discover inputs that activate each path by evaluating each path's condition. Consider the path that leads to the failure state shown in 9.6. Let's see how the symbolic execution uses the theorem prover to identify that this is a reachable path. Alright. First, the symbolic engine begins by symbolically executing the program. The inputs A, B, and C are replaced by symbolic values A, B, and A. When the engine, or whatever that is, when the engine encounters an if statement A, it asks the theorem prover, is there a value of A that would evaluate to true? If there is, the theorem prover would return yes. Similarly, we ask the theorem prover to see if there is a value of A that evaluates to false, to which the theorem provider returns yes. This means the symbolic execution engine must explore both paths. Assuming that the symbolic execution engine first explores a path where A evaluates to false and encounters another condition, this will result in a new path. Okay, yada yada yada. Again, ask the theorem prover if there exists a value. Okay, we don't need to know how that works. Okay. The symbolic execution engine will repeat this process, all possible paths. Alright. We're going to skip all that. Limitations of symbolic execution. However, there are constraints that the theorem prover can't solve. Consider our discussion of the Diffie-Hellman key exchange algorithm from Chapter 6. Recall that recovering a private key from a public key would require solving the discrete inverse of the log problem. Consider this example function originally proposed by Maru Naik at the University of Pennsylvania. Meyer Naik Alright, test. Two large primes. If POW, print, no error. Evaluating the condition would require finding a value for x that would make the condition true, thus solving the following question. Alright, we're going to skip all this. Dynamic symbolic execution. Dynamic symbolic execution combines dynamic execution techniques like fuzzing with ideas from symbolic execution. In addition to symbolic variables and path constraints, DSE keeps track of concrete value supplies as original input to the program and is completely explores the path exercised by these concrete variables. Alright, let's see what they want us to do. To truly understand the DSE's engine inner workings, consider the state of the concrete variables, symbolic variables, and path constraints as the DSE engine executes each line of the test function. Okay. Now line 1, okay, we're going to skip all this. We don't need to know how exactly all this works. During the next step, the DSE engine encounters a second. Okay, we're going to skip that. DSE. Okay, the SHA-256 hash function used in this code is a one-way function. So a solver won't be able to solve the values of x and y to satisfy this constraint. However, we can simplify the constraint by substituting our symbolic variable yada yada yada. Using a DSE to crack a password. Now this is what we want to know. Let's uncover a user's password by using a concolic engine called Angr. Angr was created by Jan Shoshit Tashishvili. Shoshit Tashishvili and others. While they are members of the Giovanni Vidna's research team in the University of Santa Barbara, instead of analyzing a specific programming language, Angr analyzes the binaries that you get when you compile a program, which makes it language independent. We'll practice using it in this section, but first we must create the program to test. Creating an executable binary. Create a folder on your desktop called concolic. Create a new file within it called sample. This is the file we'll compile. Copy the following code into the file. Alright, let's see if we even have that. Let's see what they're calling this. This program is implemented to the C program language. The program prompts the user to enter a password and then checks to see if the password matches 7,857, the correct value. If the password matches, the program prints access granted. Otherwise, it prints access denied. Alright, let's go back. If x equals 7857, print access granted, else print access denied. Okay, it's simple enough. Integer main. So this is using Python that runs on C. The heck? Enter the password. Let's see if we've got this code somewhere. What chapter are we? Chapter 10. Simple C. Here it is. I'm going to copy this. Alright, let's do that. Let's go to our Kali Linux. Alright, let's go here, and then I'm going to do the same thing I always do. I'm going to call this one Concolic. No, I'm going to call this one nothing. I'm not going to put that in here. So we're just going to put this on the desktop like I said. I think I've learned my lesson already. Create a folder on your desktop called Concolic and create a new file within it called simple.c. Oh, simple C. Alright, let's do that. Create a folder. Call it. Create file. Create folder. Let's see if that in case he wants it little simple.c. Simple C. Alright. Okay. So this is going to be a password program. This is a program is implemented in C. Okay. Terminal. It said create a folder. Oh, new file. Oh, okay. I'm tripping. Let's go here. Put this in the middle since we're going to delete it. Is it a dot? It's not a pi, it's C, but I don't know. Anyways, let's see what's going on here. Alright, open the terminal, navigate to the folder on your desktop, compile the simple C program to create a binary, the file that contains the machine code by running the following command. Alright, gcc-o simple C. Alright. Let's pull this over here real quick and then see if I can do that. So open terminal here is what I want to do. And I'm going to GCC. Simple. Error equals expected and equals or attribute before the token. So obviously the code ran into some errors. Oh, let's open this code and see. What's happening here? What is this? Oh yeah, simple.c. That's just turns it into a C program. Okay, well, let's see. Okay. Why is this giving me a huge screen? Man, bothers me. Okay. Can't edit this or nothing. What is all this crap? Oh, because it compiled or what? Did that compile or did it try to compile? Let's go back to there's an error right there in your line 9 before. Might have compiled it. I don't know. Let's see what it says. Oh, man. To create a binary, the file that contains the machine code. This program runs the GCC compiler that comes pre-installed on Kali Linux, which will compile the simple C file and output a binary called simple. Test your new binary by running the following: ./simple. I don't think it created anything. Because it couldn't compile it because of errors. What am I doing? It's just ridiculous. just trying to fix this code. So I can read it better. All these C brackets. Let's see what's going on here. I think this needs to be. I think we're missing something here. Oh, man, let me see. Okay, so include Studio H. Shouldn't this have like a hash tag here or something? Void check pass integer x init. Haven't used C in a long time, so I'm sure that's just integer. Why is it init? If x equals 5. Alright, let's try to compile this now. Hey, GCC output simple C. Same problems. All right, simple.c line 1. What? It doesn't need that? It doesn't. Okay. Okay, expected this or this or this. Okay, so let's fix that one first. I already did this. Why? Is that just, yeah, because I tried to compile it. Man. It's gonna be a problem. I've never used. Oh man, include studio.h. Maybe we can. Gosh. Alright, what else is our problem? I'm about to do this crap again because I don't know how this works. In function main, declaration of function, print f. 13. Print f. What's wrong with print f? Oh, shoot. Oh, it was taking that long to compile? What the fudge is going on? There's no P there. I have no clue what's happening here. I think this all stems from the Studio H. So we're gonna move this to trash. We're gonna create a new. We're gonna do this again because I have no clue what's happening. I've never. I've compiled this from the command line, but I don't remember how anything works. So, then I go back and I'm gonna redo this. This is the joys of learning on your own from books. Okay. I know and see we don't need these. I don't know, but it's saying there's something going on with that. We could leave all this the way it is. This is fine. It should work now. I think those just came from all this. Didn't need those brackets. Now we could try to compile it. Same stupid problem. .h. Simple.c. Unknown type name include. All right, we're gonna look at the book code because I did all kinds of troubleshooting on this. Like I looked up C code, how to add libraries is the first thing I did, and that kind of, if you look at this code, it's missing some stuff and it's probably outdated and old. So, but I mean, it gives you the structure. We can come in here, and what we can do is we can look at the book and see what the book is saying. So the book says to add this, and it's not studio. That looks like it's outdated, so it's stdio. Stdio .h. So it's that. And check pass is fine. And this guy put init, which I knew was wrong. It's just integer. I mean, you gotta look at these codes. If you're copying them, they don't work. This obviously is wrong. This one is equal. Oh, sorry. Yeah, it doesn't. Is it double equal? Might just be one equal. I haven't used C in years, but you know, print printf access granted, else printf access denied. Int main or char integer x equals 0 printf scanf and check pass. Alright, that might be okay. Let's save that. Now let's try to build it. Had to put a capital on it. In function check pass, error expected a colon before that. So check pass. Now we're getting closer. Let's see what this did. Check pass. Int x. Yes. If yes. Oh, it's missing the semicolon here. Will it let me edit this? Or no? Papa won't let me edit this, man. So I was opening that with Vim. That's ridiculous. Just ridiculous. There you go. And so, moral of that story is, what I've learned is on the book, if you're gonna use a sample code that they have on GitHub, even that's their book. We humans make mistakes. He made some human errors by copying this code in from the book to make it easier for us, but he forgot the hashtag there. He put init x there, and he forgot the semicolon right there, or whatever this is. Yeah, semicolon, or not semicolon, colon. Anyways, he forgot stuff. So check your book. I'm assuming that they copied this from the book by hand. So, to help us out or whatever, or something, but it's got an error. So, moral of the story is, that's what my channel is about. Run it. If it doesn't work, troubleshoot it. I updated this. I googled, how to add libraries to C, but I took that video out because it was way too long. It was like an hour of me just troubleshooting the code. So I did all that for an hour, and it got me closer and closer. Basically, I was noticing he was missing stuff, but ultimately I figured it out was going to the book and looking at what the book was showing and what that code was. And so the book showed it had that, which I was right. When I looked it up, it said that. And it was missing this, and so stuff like that. So yeah, just if you're gonna use this stuff that's already written, know that humans make mistakes. In this case, they did. But we can move on now. That only took an hour just to get the stupid code running. That's the beauty of learning by yourself, but you know what? You can learn a tremendous amount by yourself. I learned a lot. Okay. Now let's run this simple C. Okay, so /simple. So let's go back. Since it works. /. We had it, but I changed it to a big simple. Sudo /simple. Alright, so it's called simple. So we're gonna go sudo /simple. Access denied. Oh. God, I'm slow. It's running the program. Oh, help me. Yeah, so now it's running the program, enter password. Access denied. Okay, so that's good. What the hell was the password again? 7857. Access granted. Ain't that cool? That only took 4 hours. No, just kidding. Alright. So that's obviously working. That program's working. Let's move on to the next part of this nightmarish Halloween episode. Alright, installing and running Angr. Now we're getting into some cool stuff. Okay, so we recommend that you run Angr within a virtual Python environment. A virtual environment isolates the libraries that Angr uses from the libraries in your regular environment, which reduces errors caused by conflicting versions of libraries. Run the following command to install Python's virtual environment wrapper. Virtual wrapper. And it's in its dependencies. Sudo app bit python dev build central virtual wrapper. I guess let's build a virtual wrapper. I mean, I don't. Eh. Let's see what we got here. Alright. Sudo apt-get install Python 3 dev library FFL FFI dev build essential virtual man, that's a mouthful. Is my internet not working? Oh my gosh. Alright, I had to reset my firewall and everything. So I guess let's go back into here and see if we can. There you go. Alright, looks like it's working now because I have internet connection. Said it couldn't find this one, but I guess that's okay. It's probably good enough. Let's see what else this says. Next, configure the terminal and activate the virtual environment wrapper. Next, configure the terminal and activate the virtual environment wrapper, which will allow you to create a new virtual environments. Source, user, share. Virtual environment wrapper, virtual environment.sh. Just check that. See what that does. Source. User. Share. Virtual env wrapper / virtual env wrapper .sh. Motherfucker. So he's in Cali. I don't understand where he went. So what does that mean? He was in Cali. Created the program desktop. Now he's in the desktop. A, B, C, D, E, F, G, H, I, J, K, virtual box. Nope. And I'm not going to care about this virtual environment. Why did it say this was... So it doesn't interfere with our other libraries? Sudo apt-get install blah 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 virtual wrapper. So it's probably not due. It failed to fetch this. So obviously this stuff is outdated. Okay, enable to fetch some markers. Maybe run app update. So we'll go app get update virtual env wrapper .sh. What? Man, that just. Oh man, I hope my internet didn't. Oh, it's working. Doing something wrong here. Says next configure the terminal and activate the virtual environment wrapper. Maybe. It has to be like that. Typed something in wrong. USR share virtual and virtual NV wrapper, virtual NV wrapper, virtual NV wrapper. Let's see. Let's just skip that. Make director make virtual env python what the hell the heck this is. mkvir command not found because what? It didn't want to download this stuff. It's right there. How is it not found? I found it right here. So this is going to main. Cali rolling. Main Python stevedore. Main. Main AMD64. Okay, fix missing. When you use fix mix missing. Alright, so I just YouTubed how to set up a virtual environment with Python. Let me look and see what the book had us doing. Okay, so the book had us getting this virtual wrapper. I don't know what. What is all this? I don't even know what that is. Make virtual environment Python, then your version. Then they called it this. Right? Okay, so the easier updated way, I think, I don't know, is so I just put virtual env, right? That's the same. And then I name it my temp VMV virtual environment. So created it, and I just did it on my desktop. There it is. And I checked my Python version because he did. Then source is how you activate it. My temp VMV bin activate. So this has got a bin in it, whatever, and it activated. There you go. Now I am in my virtual environment. Okay, see, it went to bin and activated it. Because it's Py, right? Python. So that's an easier way. You can pause it, copy, follow, but that's a way easier way to do a virtual environment, I guess. I don't know what this guy is doing or what he used, but Yeah. So where is the... Anyways, so... And here's the video I watched real quick and how he set it up. If you want to pause that, copy that, you can. Pause that, copy that, you can. But it worked. And what I can do is I could just go here to hack the file. We could do here, create folder. Create document. Come here, and I can copy my instructions. Right here. So I'll put name of virtual. There you go. So that gives me a little instructions, right? Enter virtual name of virtual environment /bin. Gives me some instructions how to create a Python virtual environment. So now I'm in it. All right, now we can move on. And so we're gonna skip that crap. I don't know what all that crap is. Pip3 install Angr. So let's install it in that virtual environment. So I have it installed on my box too, but I'm not going to use it on the box. I'm going to use it in this virtual environment. Okay, it says it was successful. All right, so we figured all this out. We worked our way through it. We did everything the book said. We're in our own virtual environment. We installed Angr in our virtual environment. We're here. We just named it something else. All right, let's move on. Angr is a well-documented Angr is well documented. Before you continue, I recommend that you read the core concept section of Angr documentation. Also, try completing the Python interactive shell exercise listed. So, like always, we come here. That's not found. Alright, that's fine. The Angr program. Now let's write the Python program that will use Angr to automatically discover the passcode in the program we wrote. This is actually very, very interesting and very, very useful, because if you have people that are writing code and you want to find passwords or anything in their hard, if they encoded it, and they do it all the time, they hard code passwords, all kinds of stuff in there, by accident or on purpose, it doesn't matter. But that's how you can hack a lot of stuff. I'm sure you can use this on GitHub. You can use this on code. We're about to read and find out how this works, but this is very useful and very interesting. So this we don't want to skip, right? I'm gonna have to take a break though, because I'm kind of tired. I've been doing this for a while, but we're gonna come back to this and see if we can download this. If not, I'm gonna have to type it. So, all right, let's look in here. And see if they've got. They do. And this is not gonna run probably too, so we're gonna have to get this crap to run too. Oh, man. Let's see what they want us to do. All right. New file on the desktop. angersim.py. All right, let's do that. Paste, save. Let's see if that works. If it doesn't, we'll troubleshoot it. We import the binary from Simple C program as an Angr project. Import Angr, import system. Project equals Angr project simple, but we named it simple with a big S. Initiate initial state project factory state. Before we continue, keep in mind that the symbolic variables you'll inspect will be bit vectors representing the context of symbolic registries. This is because your symbolic execution a binary rather than a source code. Next, we obtain the initial entry state of the program. When we then pass the state of the simulation manager, it will manage the process of simulate program execution. If you wanted to manually simulate the program, you can run the simulation step. Allow you to inspect the state of each path constraint at each execution step. The Angr documentation walks through this process with a simple example. Now we'll define a function that identifies the success state if the state would output the string access granted, the function true. Okay, we can skip all this. If the state output of the string, okay, denied. Now we can start the calling execution process. Then we pass the function pointer to the success failure function. If the simulation reaches a failure state, it quickly terminates and restarts the search. However, if the simulation discovers a success state, it terminates and saves the state. Finally, we print the input. It causes us to enter the success state, and voila, we have the password. Use the terminal run Angr Okay, let's see. Well, why put it in there? I could just put it in the virtual environment. It's just ridiculous. So let's take this, copy, let's go to here. Let's open that. I think it's not simple. Oh, because there's on the desktop. Yeah, that is that I popped out. Let's see. Put that in the virtual environment. I did. Okay. Where did I put that? We import the binary from the simple.c program. Okay, so that would be the binary. Oh, look, I found it. 7857. That worked. Okay, so um, that works. That's pretty cool. Why am I on desktop? Oh, because that's where I started the virtual environment is on my desktop. I'm running it from there. Yes, I'm running it from a virtual environment. I'm grabbing it on my desktop. That's where I'm at, I guess. And I found the binary 7857, and that is my passcode. That's pretty damn cool. That worked pretty good. So, do I have that set up? I've got the Angr set up. I want to take the Pi copy because that worked. Put that in here. Go to my. I'm gonna go to. I'm gonna make a new. Well, I'm gonna make a new folder. I'm gonna call it Angr. Pi. I can go here. I could create document. Say instructions. Fucking spell. And I'm gonna say run. Let's see. Save that, I guess, and then copy that. Paste that in there, and there's that program. We would just have to adjust this to the program that we want to search it. We want to compile and create. So I want to go here. So I'm going to say run. Where is it? Ha! Where is that? G. Up right here. So run. Let's say GCC output. program in C. I think I spelled that right. So what that does gives you some instructions for this binary file to run through this program. Okay, and there you go. So that's pretty cool. So theoretically, whatever program that you run into, if you get the source code, you can run through this and it will look for binary, anything in there binary, hard coded in there, I guess. I don't know. And it'll find passwords and stuff. So it's not too bad. A little tool or a little exercise to do. That's the power of like Python and um, what we can do is we can take this, put this in, hack the file, and that environment we'll leave alone. Leave those there too. Yeah, it's not gonna move, so not a cool. It's not a bad little tool. This is all Python. Python is powerful, right? You can do a lot of cool hacking stuff with Python. Everything worked. So let's go into back into the book, and we're not going to do the exercises, but I think we're done. These exercises are designed to round out your understanding of concolic execution and fuzzing. Exercises are listed in order of difficulty, and I recommend attempting more difficult exercises as you truly master these topics. Happy hunting. Capture the flag. In this chapter, we looked at only a small fraction of Angr is capable of. Expand your understanding of the tool by completing the Angr capture the flags. And so here, we can go here, and then it's going to give us all the little programs to look at, I guess, and then we can find stuff and run stuff. So if you want, download, pause it, see if you can get to that, and or this, and you can practice yourself. Also contains solutions. We're not going to do it. Fuzzing web protocols. We've explored how to fuzz binaries. Let's look at an easy way to fuzz network protocols using the Spike tool that comes pre-installed on your Kali Linux. So you can fuzz. So if this fuzzing is trying to get the program to crash, right? You can pause it, practice all this. Your own concolic execution engine, fuzzing open source projects, real programs. You can pause it, go to this, fuzz some real programs. But I think we're good. I think we're done. And we're going to move on to something different. But that was a lot of information to take in. It was a lot of fun, I would say. I had fun. This fuzzing, you're going to get a hold of a program, and here's a Python program that you can use to fuzz the program with, right? So we use Python to create a fuzzer and a program to fuzz. And that's what that test function is, right? So we got it to crash. And that's what you're doing. You're trying to get these, you're messing with programs, you're cracking passwords. I mean, it's pretty cool. And this chapter, what I would say is practice this chapter more if you want to get into this kind of stuff, right? Get your tools ready and do that. So, anyways, we're off to the next one. So, that was Hack the File. I hope you had fun. I did. I had a lot of fun. And I'll see you next time. Enjoy.